All right, in section 1.14, we are going to be connecting infinite limits and vertical asymptotes. We've already done some of this intuitively when we first defined one-sided limits. So we've kind of come across this situation. We're just going to formally define vertical asymptotes in this section. All right, so a graph like this, y equals 1 over x squared, and we want to know what's going on as x approaches 0. And so this is kind of review for us. We can see that as x approaches 0 from the left, our y values just skyrocket towards positive infinity. And as x approaches 0 from the right, we have the same behavior. Our y values are approaching positive infinity. So even though the left hand and the right hand limits don't approach a value, they do have the same behavior in that they are getting infinitely large. So it's okay for us to express that behavior as the overall limit as x approaches, 0 for 1 over x squared is positive infinity. So while it doesn't approach a value, we do say that since from both sides the y values are approaching positive infinity, the overall limit approaches positive infinity. So the intuitive definition of an infinite limit will be just that. The function has to be defined on both sides of a. Then the limit of f of x as x approaches a equals infinity means that values of f of x can be made arbitrarily large by taking x sufficiently close to but not equal to a. Same idea for negative infinity, right? So if as your function gets close to some value a, your y values get infinitely large negative by taking x sufficiently close to a, then we say that the limit of f of x as x approaches a is negative infinity. Has to be the same behavior on both sides of a. But we can also define one-sided limits for this situation. So the limit of f of x as x approaches a from the left equals infinity would just be that the function is only defined on this one side of a. And as we get close to a from the left, our y values get infinitely large. Same idea in a situation where you have the limit of f of x as x approaches a from the right being positive infinity. And then you can have the opposite behavior. So the left-hand limit approaching negative infinity and the right-hand limit approaching negative infinity as well. We use all of that to give a formal definition of what a vertical asymptote is. And so the vertical line x equals a is called a vertical asymptote of the curve if at least one of the following statements is true. So either the overall limit as x approaches a is positive infinity, the overall limit as x approaches a is negative infinity, or any of the one-sided limits as x approaches a are positive or negative infinity. In any of those 6 cases, if one of them is true, we have a vertical asymptote at x equals a. All right, so let's remind you how to use your calculator, but find the right hand and the left hand limit as x approaches 3 from the right and the left of the graph of 2x over x minus 3. 1 second here. Sorry, my smart pad connection isn't working, of course. There we go. Okay. So we want to look at 2x over the quantity x minus 3, and we're going to look at it from the left and the right separately. I'm going to make sure my table setup is set so the independent variable is set to ask. And then I'll go second graph to go into my table. This is just old stuff. And we want to approach 3. So let's start from the left of 3. So that would be like 2.9, 2.99, 2.999, 2.9999. And you can see it looks like my y values are just getting indiscriminately large negative, right? So as we get closer to 3 from the left, my y values get large negative. So that's negative 6 times 10 to the 5th power. All right, so now let's see if it's the same behavior from the right. So I could do like 3.1, 3.01, 3.001, 3.00001. Okay, so the y values are now getting large positive. So it actually has the opposite behavior. So going back, go ahead and write our answers here. As we approach from the right, our y values got large positive. As we approached from the left, our y values got large negative. So what's going on in that graph is we have a vertical asymptote at x equals 3. And as we are approaching 3 from the left, our y values get large negative. So that actually looks something like that. And the opposite, as we approach from the right, they get large positive. Okay, find the vertical asymptotes of f of x equals tangent x. So a little trig here for this one, what we do want to know is that tangent, there's an identity. We can write tangent in terms of sine and cosine. So tangent equals sine x over cosine x. So let me write that out a little bit more explicitly. And so you end up with a vertical asymptote when you have an infinite limit. And that's going to happen when cosine approaches 0 while sine approaches some other non-zero constant. And actually it'll be sine approaching 1. Okay? And the reason it happens like that is because think about what dividing by a small number does. So when we approach 0, we're just approaching it with very small numbers, right? Like let's say 0.1, 0.01, 0.001, and so on. Well, when you divide by a small number, let's convert these to their fractional equivalents. That's a tenth, that's a hundredth, that's a thousandth. Remember that when you divide by a fraction, so like 1 divided by a tenth, you flip it and multiply. So that ends up being 1 times 10, which is 10. So then like 1 divided by 100th, whoops, ends up being 100. 1 divided by 1,000th, keep doing that, equals 1,000. So as my denominator gets smaller and closer to 0, the overall fraction will end up being larger and larger, giving us an infinite limit. So what we want to think about is, okay, well, when is cosine 0? And that's what our unit circle is useful for. And so here, the quadrants are going to be the most important angles for us. So that's the coordinate 1, 0. And remember that any point on the unit circle is cosine of theta comma sine of theta. So the x-coordinate is cosine of whatever angle you're at. The y-coordinate is sine. This is 0, 1. This is negative 1, 0. This is 0, negative 1. All right, so what we're interested in is when cosine is 0. Cosine is the x-coordinate. That looks like here and here. So there are infinitely many angles that works for. But the first one, so just rotating through, that's pi over 2. And then we keep rotating through, that's pi. That's 3 pi over 2. And then back here, that's 2 pi. And then we could keep going. That's what, 2 pi plus pi over 2. So that's then 5 pi over 2, and so on. But every time we get to one of those two quadrants, cosine is going to be 0. So tangent is going to have a vertical asymptote at that point. And so if there are infinitely many of them, we just want to establish a pattern. I'm going to say my answer is the vertical asymptotes for tangent are at x equals pi over 2, okay, and then plus n times pi, okay? Because this is my first one here, and then I have to go a rotation of another pi radians to get my next 0 for cosine, and then I have to rotate another pi radians to be back at that vertical quadrant. And I need to make a statement about n, so I'm going to do this. And this represents the set of integers. All I'm saying here is that n has to be an integer, right? So it has to be a positive or negative whole number multiple of pi that you're adding to pi over 2, and that'll get you your vertical asymptote. So let's get a visual of this. Get out of here. So there's my tangent graph, and I said, okay, x equals pi over 2. Good, so you can see that that's a vertical asymptote. X equals 3 pi over 2. There's another vertical asymptote. X equals 5 pi over 2. And so on, every time we add pi or subtract pi, right? So if I subtracted pi from the first one, that's why we said that n multiplier just had to be an integer. So it could be like a negative 1, and we would get x equals negative pi over 2. Oh, whoops, pi over 2. And there we go. That would establish all of these asymptotes, and so on. Okay, here's your student example. It says the vertical line x equals 2 is an asymptote for the graph of the function f. Which of the following statements must be false? So take a look at that, come up with your answer, and we'll go over it in the next class.